Now we're going to start section 4.4, which is on spanning sets and linearly dependent versus linearly independent. All right, in order to be able to understand spanning sets, we need to go over what a linear combination is again. So that's what we went over in section 4.1. So let's just review it by doing a quick problem. So number 1, I want to write, if I need it to be a pen. So I want to know, is the vector 5, 8, which I'm going to call V, can it be a linear combination of set A, which is the set containing the ordered pairs? I don't know what happens sometimes. The ordered pairs 1, 4, and 3, 0. All right, so as we did this before, I want 1, 4 as a column, 3, 0 as a column, and I want to get out 5, 8. So we're going to row reduce this one. This one isn't that bad. So I'm going to leave 1, 3, 5 as my top row. And then I'm going to do row 2 minus 4, row 1 for the bottom. So 4 minus 4 is 0. 0 minus... Oh, there was a much easier way of doing this. I just looked. Hold on a second. So let's go back and make this a lot easier. Divide the second row by 2. I'm sorry, divide it by 4. So I get 135 over 102. Then subtract. I'm going to get 135 over 0.353, which would then be, I'm going to get with 102 over 1011. So I did row 1 minus row 2, and then I divided row 2 by 3. So this tells me my first scalar is 2, and my second scalar is 1. So what this says is 2 times my first vector of 1, 4, plus 1 times my second vector of 3, 0 should give me 5, 8. Check it. 2 times 1 is 2, plus 3 is 5. 4 times 2 is 8, plus 0 is going to give me 8. So yes, I can write the vector 5, 8 as a linear combination of what's in set A. All right, so we need to know that. Let me go over another one. Just people tend to get this one wrong a lot. So number 5 in the notes. Can I write V, which is the matrix 0, 0, 0, 0, as a linear combo of set A, which contains the 2 by 2 matrices 2, negative 3 over 4, 1, and 0, 5 over 1, negative 2? And most people go, no, but it actually is very quick and easy. I can do, just for shortness, let's say this is B and this is C, so it's easier for me to write. I can say 0 times that first matrix of B plus 0 times that second matrix of C is going to give me 0, 0 over 0, 0, or matrix V. So yes, we can. That is not a problem. So if I can write it as a linear combination, that is a scalar times the vectors or matrices or whatever I'm given, then all added or subtracted together. All right, so the next thing we're going to get into then is spanning sets. And what a spanning set is a set of vectors that when I do a linear combination of them, I can get anything I want. So it's better to me just to kind of explain what's going on. So number 6 in your thing, I want to know the most basic set, most basic set that spans R4. So if I am asking for a set, make sure you give it to me in braces. And I want something that spans R4. So when I add them together, I want to get something in R4, which means these have to be 4-dimensional orderings, ordered quadruples. So it would be 1, 0, 0, 0, comma 0, 1, 0, 0, comma 0, 0, 1, 0, comma comma, 0, 0, 0, 1. Now I can use those 4 in some linear combination to get whatever I want. So for example, if I wanted to get 1, 2, 3, 4, I would do 1 times the first one, plus 2 times the second, plus 3 times the third, plus 4 times the fourth to give me that. And I can go ahead and get that. So any ordered quadruple I wanted, I can get from something inside that set, from a linear combination of what's inside that set. So that would be a spanning set for R4. Well, not only can we do these with vectors, we can also do them with polynomials. So I want to know number 7. And I'm going to rephrase it a little bit. And I'm going to say, what is a basic set that spans, all right, P2. P2 is a different thing that I haven't shown you before. So P, it stands for polynomial. 2 is the degree. So this is all second degree polynomials. So the set that does that, I would need an x squared piece, I would need an x piece, and I would need a 1 piece. So the most basic set that spans P2 is the set containing x squared, x, and 1. Notice there are no pluses and minuses in there. I just want to know what are the pieces that I can do a linear combination of to get what it is I'm looking for. So if I want 2x squared minus 3x plus 5, I would do 2 times the first piece minus 3 times the second piece plus 5 times the third. So those are the pieces I will use to do my linear combination. All right, so the definition of the span of a set is the reverse. The span is what I get out of a set. A spanning set is something that I can get everything in that set from. The span of a set is what I actually get out.